All right. I hope everyone is back.
We'll go back, guys.
Okay, so we were discussing about the principle of modularity and how the word software that you use write your stuff. It really adheres to this principle, and you can actually add, let's say, an AI assistance to that. It has a functionality of spell checking. This is a totally, a modular thing within the whole software package. Okay, the third principle within the component-based system design is the composability. So this principle says that the component can be combined to build a larger system. Usually components are composed of components like opposed. The bigger components are also part of the composition from the small components, and everything is like built up from ground up basically. And that's how when you build your system, you should think of composing your system from your own components that you build, or from the components that you take it from third party and glue them together. So the whole principle of composability is that it should be like the system should be composable. So can you think of an example that comes to your mind when you say, oh, this is a really, really good example of system design that follows the composability? When you see the composability really in very, very clear way that you can appreciate the composability.
The libraries, for example, the graphic libraries, where composites of many components that do a similar thing, and those are used in the projects also.
Yes, so the graphical libraries are also a good example. Yes?
Spotify is reusing a lot of the same components as well. When they're for better, like you click on the specific music with the title and so on and so forth, but they're all the same component.
So let's look into the e-commerce platform. So you have a shopping application, right? And you have a lot of functionality that they're all independent. You have cart, you have payment systems, and then everything is combined to give you the wholesome experience of the shopping, right? So each of these components are they just in the final system they are built by the principle of composition, and then they each work seamlessly with each other. Or let's think of another example. In your smartphone, you have camera, you have the basic hardware that exists, right? The screen, touch, or like GPS, accelerometer. All of these are different components that they exist. And when you're building a mobile application, you basically are composing these components together, stitching all these components together, and having an app which gives you certain user experience. So this is also a good example where you see the principle of composability. Some of you have done the mobile software development work, the course, and in that we talk about the UI, the modern mobile software like sort of UI is built based on this principle of composability. So for example, here is an example of one of the popular framework for Android development, it's Jetpack, where you are kind of, the way you see the UI screen, the whole things that are drawn that you see on the screen in your app screens, they are basically nothing but the composition of the small pieces that you built on the screen. And in the end, your the framework basically composes all the bits and pieces that you put together and gives you this whole screen experience. So this is also a classic example where you have the components and then everything is stitched together to give you a final screen. So you do the composition, you have the columns, the rows, and the layouts, and then you compose basically the final screen, where the final drawing happens. Before that, we need the under the hood. This is following the principle of composition to give you the final screen. It builds the tree, and from the tree it takes to the drawing of the screens.
I haven't said.
Yeah, so in this whole, of course, we are not going to go into deep. This is again itself is a really like deep subject of how the drawing and the composition happens that we will cover in the different course. Okay, so when you have, let's say, what is the advantage of this whole recomposition approach is that if you need, you can actually recompose a small part, or you can recompose the whole screen. So, for example, if you have a mobile screen, let's say, of an app screen where you have a lot of functionality, right? Only a piece in that, or only a part in that function in the screen changes. Let's say some number. So, for example, here in this example, if I click on this screen, I get this increment on this number that you see on the screen. So, if I were to click and then refresh this whole screen, I just click on this and this only this number, the number, this counter basically, only that part gets refreshed in screen and not everything else. So the beauty of this whole approach of composition is that the compilers actually can really in a smart way can compose by tracking what part of the system changed, what component changed, and based on the only change component gets refreshed, and they can build the whole screen based on what has changed. So they also keep track of what has changed, and that's possible because otherwise, if you have this static thing, then you have to reload the whole page every time. Then that's not a smart way of doing so. But because of all of them adhere to the principle of composition, they can track which part has changed, and based on that, they can redraw the whole screen. And all of the modern sort of UI frameworks that you see, they actually adhere to this whole principle of composition. This is an example of from Android development. Of course, other language also have something similar. Yeah, so only change state. Like I don't want to confuse you with the sort of deeper concepts about the states and in the Android ecosystem, but just to put this point across that hey, the advantage of composition is that when you are determining what was displayed on the screen, when the compiler composes the whole thing, it can smartly know which part has changed and do the recomposition in a really smart way and time and efficient way, the computation efficient way. And that's only possible because these frameworks are built by adhering to the principle of composition, where they build the screen using the composition. Okay. Now the next principle in this is encapsulation. Basically, it says that the internal implementation details when you are building a component or system, then you have basically only exposed the interface, and the internal details are not necessary for everybody to know. So you basically hide the internal implementation, and only public interfaces are exposed. Can you think of an example where you see and can appreciate this principle of encapsulation, where you see, I see that this system is really important with encapsulation principle in the day-to-day system that we use. Yes?
You mentioned the data of SDK.
Yes.
Kind of based on this.
Yes. All the payment systems, there's tons of things that go in the background to make the payment work, right? And handle all sorts of failures and everything. But as a developer, you only care about the interface, and that's all you know. You don't need to know the public key. So, yes.
Yeah, so that would also be authentication, like passwords, like and how the company also stores the passwords.
Yes. Yeah, all the OAuth providers are also an example where they just isolate everything from you, all the internal logics that they isolate from you. So that's really good example. Other example, very common one that you have probably seen, the databases, right? You just have the query interface for you, and you don't know the internal things of the database that you interact with, and that's primarily because they adhere to the. And so why is it important? Because when you are building a system, you have to think about, okay, what does this component do, and what it needs to expose to outside world, right? Because if you keep it open, then of course you are vulnerable for intrusion and all sorts of things. But that's why you have to have a clear thinking about in terms of each component, what they encapsulate and what they sort of expose to the outside components or outside world. Yeah, or the payments API that you just talked about, that's also a good example. Okay. Another one is in the same series is extensibility, which is basically components can be enhanced without affecting the existing functionality. That's sort of the underlying principle behind this. And where do you see where you can appreciate the extensibility aspect of your system design? Where is this?
Might be a little small, but the password is a text field where you
Password text field.
yeah, so like it's hidden, but it's like essentially a text field, but it's hidden, and then you can show or not show.
Yes, so it's also an example where it's an extended functionality that is not optional. If you want to use it, you can use it like that. That's a really good use case. What else? Maybe, yeah. What else comes to your mind when you see this principle really standing out in the applications that you use in your daily use? Anything? Please.
Like actual, like I mentioned before, extensions for the browser, like where you can add functionality without changing how it works.
Yeah, extensions, browser extensions, or extensions that you add in the, let's say, the Word, the processing. So yeah. So that's also an example of extensibility that you can basically build report. Okay. So you, for example, you mentioned about the password, but the two-factor authentication is also sort of an extensibility of your existing login functionality. You are basically providing the extra features on top of that. So that also adheres to the principle that, hey, even if you don't do two-factor authentication, everything will still work, right? And it's not going to break your system. It's not going to affect your existing functionality. That's sort of main principle behind that you should keep in mind when you are giving extensibility. Was browser password manager and everything that you mentioned. Okay. Okay. This is also really crux of component-based systems is the whole principle of interoperability, and that's because when you are using the components from the public repositories or from the component repositories, they have to work with other components, because that's the main idea behind this. That the component that you build yourself or you take it from others, they have to work with each other across the platform and environment. So let's say you have a part of system that some part is running into a technology stack, other part is running into the technology stack. How do you make them interact and work? Now you might say, hey, we have the REST, but REST is sort of latest thing that we have in this sort of component-based approach. But prior to REST, how were like sort of things were interacting? Of course, REST is the latest sort of layer in which you can see that it has really solved the interoperability problem in really big way. But prior to REST, how were they communicating? And some of the examples that we will see in today's lecture itself. Of course, yeah, as I mentioned, so REST does sort of makes things interoperable for you. You can have a component running in a particular environment and setup, and then you can interact with that, right? Yes, of course, the Google Drive integration is also an example of interoperability. You have it working with the collabs and all sorts of tools within the family of Google's product. Of course, maintainability is also a big part. As I mentioned in the starting, 80% of software is all about like refactoring, rebuilding, adding something, changing something in the existing code base. So when you are building the software, it has to be like adhering to you should build in a way that it's maintainable. It's not, otherwise it's going to fail. Yeah. And classic example we all face is if you have used Windows, it's really pain, of course, but it's really good example of where it shows that hey, the software has to be maintainable, and all the updates that you make, of course it breaks sometimes, but it's really good example that you send these patches and they just do the needful and everything else sort of works seamlessly. And this is going to be the case with any system because you are never going to make the perfect system in the first go, right?
Sorry, is that a typo with CBSE?
Yes, also.
Or like with
Yeah, it's a typo, sorry. It's a component based system again, sorry. Yeah, so this is a really good example where when you're building a software, you have to have the things in mind. If I need to patch something in this, if something doesn't work, there is a vulnerability, how would I address that, right? The framework, the firmware updates that you see in your smartwatches or other tools, on periodic basis they do the firmware update, like how do they do that, right? And that's because they adhere to in their design philosophy, they adhere to the principle of maintainability, and they craft the architecture in a way that it's updatable, right?
So it's basically what Android is currently doing is that instead of having a monthly large update in the entire phone where only a few components is being updated, they are going to add them to the Google Play Store, for example, and then just update them in smaller batches when needed.
Yeah, that's also I think a good example of it. All the Android sort of ecosystem in the stack, app updates, all of that you see are following this principle of maintainability because you see the regular updates. Of course, these are the deeper topics. How do they do it? Like how do they push the updates into the system? That's essentially out of the scope for this. But that's where the really crux of the design lies into that you make the systems in a way that you can push those updates and make those changes in a running system.
Yeah, I only know this because sometimes when I update my phone, they do sometimes come up with apps that I've never installed that they suddenly want to update. They usually have like very low scores, but that's because people are like, I can't uninstall this and I don't want it. That's when some of the comments is like, that's because it's a system component that they allow.
Yeah, you have system apps, you have
use for smaller components, so they can update them individually.
Okay. Now the key principles are over. Now let's look into what do you get? If you build a system by adhering to these all the principles of component-based development, what do you get? It's like fast development. Why fast development? Because you can use some of the existing components and stitch things together to speed up the process. You don't need to build everything from scratch. That's the main philosophy that we saw, taking example from other engineering domain. That's the same principle that they want to follow. Scalability, of course, you can scale your system by following the CBS approach. Cost efficiency, of course, if you are not building everything from scratch using the reusable components, either of your own or somebody else, you are making the development cost effective. Improving quality, if you that the systems are adaptable for changes and reliable. Maintenance and platform independence. So again, another big feature is that if you read these principles, the components are independently deployable into different environments, and they can interact with each other. So they offer you platform independence to a certain extent. Okay, now let's talk about the main question that everybody has in mind. How do you go about the componentization, and what is the right way of componentization, and how do we know how much to componentize? So again, the componentization method which basically specifying how you go about this whole process of dividing your bigger system, bigger use case into smaller components, right? And then there is this issue, if you make too many components, then you will end up making like the too much component calls, and that's like sort of waste of time. And system becomes also like in terms of computing resource that time that you spend, it's over componentization has its own problem, under componentization has its own problem that we saw. Like it will not be maintainable, it will become clunky, and it will become like a big chunk, and so all of that is there. So that's why you have to find what is the right sort of componentize, and that would vary from business use case to use case. You have to have a deeper understanding of the business use case to actually do the right componentization. There's no one formula, magic formula that tells you, okay, this is a good. Of course, there are some metrics for like doing the calculation whether this is the right sort of right balance of componentization. But in general, this is like it varies from use case to use case. You need to see whether what sort of componentization would make sense. Yeah, I hope this point is clear that over componentization has its own limitation that you should be worry about, right? Because then integration becomes really challenging. Most of the time is like spent then in API code. Same goes with the microservices, right? The whole principle of make everything as a microservice. Of course, you can make everything as a microservice, but then most of the time that you spend is like a microservice is communicating with each other and not with the user interaction. So again, there's a sweet spot that gives you like the best of the componentization approach, like cost in terms of cost efficiency, in terms of building, and also the resources that it consumes when you are interacting with it. Of course, the integration cost is the main thing that you should be like sort of keep in mind when optimizing the componentization. Okay, one of the examples that I think you were mentioning about the phone, the different what is the right. So, for example, take a use case, a concrete use case, and see, okay, this seems like a right componentization, and this seems like an over componentization. So let's look into this example of any social media platform that you see. They all have these features, like for content management, they have the feature like they have a component for content management, messaging, notification, ad management, and let's say profile management, right? And in the same, let's say, to speak one example, notification component. Instead of within the notification, you could have different kind of notification, right? So you could break down to, okay, I have a separate sort of component that handles the comment notification. I have a separate sort of component that sort of for like that only caters to like notifications. Like you could get into those nuances of over componentization, and that sort of would increase your system overload, rather than if you have just simple one component that takes care of the notification services and type of within the notification. You could have different kind of notifications, and then one component takes care of that, and instead of they talking to each other. Similarly, you could have, let's say, feed, like you see the, like you see in a social media platform, you see the feed, you see the different kinds of posts, you see the just text post, you see the post with just images, you see the post with the video, like you have different kinds of posts, and like if you just start building component for each, it's an example of over componentization, rather than having a single like the component of feed that takes care of different types of the content that you would put in. I hope that this is kind of clear, like why you shouldn't do the over componentization, and again it will vary based on the use case to business use case that you need to be like, and that comes with the experience to see what kind of composition or componentization basically would be the right one for this.
Quick question to the previous one. For the fee management program, would it still be overall componentization to just make the fee management component, but then still have the smaller components you have like you started talking about at the beginning of having smaller components you combine to make a bigger component.
Of course, the feed management itself is a combination of other components in there.
Okay,
But
so
it's like within the feed management, you don't go by small the components for different types of feed. Like it's like sub feed. But of course, within the feed, when you're building the feed, you will have different kinds of components.
okay.
Yeah, and then you don't go and repeat the similar things for similar kind of tasks. For different kinds. Of course, if you say, okay, I will separate, let's say, the feed management for image within and feed management for just simple text. Within that you will have some components for sure, but you don't make them like
But they're similar enough that you can just make them as one component instead of just
yes. Of course, within this component you will have subcomponent. I'm not talking about the subcomponent within the system. This is more about for a similar functionality which has like it's they're logically same thing. And that's why you, instead of putting them together separate, it doesn't make it makes sense to make a single component and then yeah.
Yeah, that can handle both.
Yes, that can handle both.
Text
Yes.
and video.
Yeah. Okay, so we talked about the components and componentization. Then there is another concept of component models. Basically, component models are the frameworks that actually. So the component models. Now we talk about okay, everybody builds their components and puts somewhere for you to use, but for them to be effectively used, they should have a standard definition. They should have a well-defined behavior and sort of well-defined structure, and that's where this whole concept of component models comes into place. Component models are like sort of like the boss or the organizers, basically they dictate basically how the component should be built and how they should be managed. So you have different kinds of component models that they specify how the structure and behavior and interaction of a standard component would look like. So for that you have a typical component model would tell you the interface definition, the communication standard that it expects between its different components, deployment specification if you need to deploy a component separately, how would that take place, what services it offers, and how like the services basically it supports. All of this will be like the specification of a component that can be served via this component model. So component models are like sort of governing sort of principles or they give you structure within which your component can live and survive and interact and all that. So these are the big picture guide. Basically, they give you specifications of how the component would be combined and all of that stuff. So there are a couple of examples in the course. Of course, for today we will see this example of Orba component models. It's really obsolete, but just to give a sense of how they were, I just included this example. But for the course, we will of course touch upon enterprise Java Beans and then also Spring framework, Spring, which is one of the latest one in this sort of category that helps you actually serve these components in a really efficient way in an enterprise level setting. That's what we are going to cover in the course. But in nutshell, they are nothing but sort of like the guiding principles, how the components would be and how they would behave and how to interact with them. They will take care of their life cycle management and all that thing that comes with the component. So for that we have different component models. Enterprise Java Bean is one of them. Then Com plus Dcom also is one of them, and they have standard interface. Don't worry too much about this, but just understand that they are the sort of standards for basically for serving the components and combining the components. That's pretty much that you need to know about. We will dive deeper into each of them a little bit later. Okay. So the components basically within a component model. So model is something that helps you govern these components that you build. The three fundamental properties is interface, defines how the components will interact, services, meaning that what it offers or what it consumes. That also have to be clear definition of what it consumes and what it offers. And of course the deployment technique as to how this component would deploy and how it would exist. Is it a black box or is it like sort of that you need to export something more than the black box. So all of these have to be clearly specified within the, and again, these specifications, these standards could vary depending on the component model that you are using. Some component model could have other sort of specifications, but these are general like sort of principles that most of the component models would adhere to. That your components should have interface, services, and deployment techniques. Okay. So we talked about the component models. It offers you the environment in which you can interact with the components. So basically, a container that manages all the life cycle of your component, communication that happens within your component, and also outside with the outside world for your component, and services that you offer. Okay, so there's a list of like some of the popular frameworks that we just touched upon earlier, but this is more comprehensive list. And some of them we'll cover microservices, we'll cover core by base class, we'll cover enterprise Java beans, and OSGI and POSO for Spring. Of course, we will cover Spring in quite detail in the course. And most of these earlier ones are kind of obsolete now, but you should know just to understand their design philosophy and principles. So we will cover some of them, and we will go in some of them in detail. Of course, this again, why you might think that why there are not component models for scripting languages, right? For example, please.
Oh, sorry, did you just go at this 1 or 2 slides back? I was kind of confused, like, what is, like, say, component framework is the implementation of a component model. I was just thinking.
No, the component framework is like the component model for you, like that. Component model gives you a component framework within which you are building and interacting and managing the life cycle of the component. So think of a component is a service, like let's say payment service, right? You make this component like payment service, you deploy it, and that lives within the container and environment of your component model, and other services within your application that need to interact, they interact within these boundaries of the. Now think of like the containerization is also an example where you make the Docker component of your service, and then these different Dockers are interacting with each other, right? So that's also at a high level within the scope of microservices. Containerization is an example of this. But in general, component model is sort of standardization, and component framework is like how these things will be governed and work together with others. Yeah, so these are some of the component models, and we will touch upon them. Of course, yeah, I was telling that for some of the scripting language you might not see, because all these principles are primarily applicable in enterprise level applications, where you have complex business logic. You have to take care. Imagine a banking industry, like there are tons of services and features that you have, and for that sort of complex system, you would need this kind of container, the component management framework, because you cannot track each component individually, and once we go deeper into this, we will be able to appreciate much more why the component frameworks do exist and what they offer, and how they are really powerful enough especially for the enterprise level application, and to also help you achieve all the principles that we talk about the maintainability, updates, and all of that. You'll be able to appreciate a little bit later once we go deeper into a particular component framework. For now, just think that what they offer and like what role they are sort of playing in the big picture. Don't worry about the details for now. Okay, so there are different classifications of component frameworks. So you could have frameworks components that are coming from a standard component repository provided by third party, or you are like newly developed components. So you are basically composing them. So this is basically saying that hey, how you are getting your component. Based on that, they have the classifications of your component. And it's all, again, that's where the whole point of architecture comes into place, right? So you have to have a right architect in place to glue these components together. So everything starts from the architect, and then you just go down to what components do you need to build them, you need to source from outside. So all of that comes later. But first is the big picture. It is the architect, what you need, and how you want your system to behave. Yeah, so basically in the process of developing the component-based system, you have the creation, you have the management, and you have support. So all of the, and reuse, like that's the main sort of thesis behind this, is like that it goes through this cycle of creation, management, and support, and reuse. All the components that exist or float within your component model or your component framework in your application, you need to have, they need to undergo this 4 cycles.
I have a question.
Yes.
About like the slide. Because there is the component repository. Does the component repository contain only stuff that we developed, or can it contain also like third-party stuff? Because if it contains third-party stuff, then what's the difference between provided by third party and the component repository?
Yeah, it's like component repository could be general public component repository, and third party are again it's the same thing, but it's more of third party is very specific to your application. But component repositories are primarily for generic purpose. Let's say I think we have an example. So you for downloading all the dependencies, the dependency management that you do, dependency management framework, in the Spring ecosystem that you have the repository from which where you download your dependencies. Right? They are generic, very generic. Third party could be specific to your application. That they could either be in the public repository or maybe behind the credentials. So it's the same thing. Either you get from repository or you get it from third party. It's like third party is more specific to your application, and repositories are more generic, like generic. So let's say you have a contract with a payment provider that may not be pushing their SDKs in public place for everyone to use, right? So that would be differentiation. It's like how you are getting the component. That's a main sort of differentiator between here. It's like, okay, it's peer to peer. It's one to one. I go to you and you give me your component that I need, or it's like I go to a public place where the components are freely available. That's sort of differentiation but don't get just take the essence. Don't get confused about the terminology because they can be confusing. But in essence, there is no difference. They are more or less how do you source your component basically. Yeah. So basically, each component goes through this 4 cycle of creation, management, support, and reuse within the environment. And typically, what happens is like, let's say you have a payment service, you have a big application that runs under the inside the component framework, and let's say you have one payment service component that you provided that your application is currently using. You decide to switch. Let's say I want to use a different payment service. What you are going to do is you are going to deploy the new payment service within the container, within the framework of your application, and automatically all the other components they would automatically know that you have switched the payment gateway, the payment interface. And because of the framework in which they are all running. And that's the beauty where the component framework comes into play. Yeah, this is the same thing about like how do you basically resource your components. Okay, let's talk about the interfaces that we talk about. This is really at the core of the components, that you have to have a component interface. So, in a typical component, you have two interfaces. One is the provider interface, and one is the required interface. It's like what it needs to function and what services it offers for other to you have a clear cut definition of it. I hope you already have covered the UML like sort of component. You have covered the UML diagrams in your previous courses, right? So you are kind of familiar with the UML interface, the notations and everything, right? So yeah, typical interface would have like the component interface would have providers and required interfaces, well defined what it needs and what it solves basically. And this is essential because if you want to make them loosely coupled and maintainable, like easy to remove and all, for that you have to have standard definitions and protocols in place for them to interact. So let's look into an example. So for example, if you have an app that gets the sensors from smartphone, so you have a public interface where you have like sensor data itself, and then you have sensor manager or turning sensor on and off, and then you have like within that you can add different sensors. So I want accelerometer, I want gyroscope and all. So you have a component that basically gives you all the sensors that you need from your smartphone, right? So that's sort of component that you have, and that would have an interface. Okay, I need a sensor. The required interface for that component would be I need a sensor data from somewhere, and I need a sensor manager which allows me to add the new sensors and start and stop basically the sensor itself. Like so, yeah. So you would have the provider, the required interface. So this will again itself would interact with the other component, which is like the hardware level in your phone, and then get the data, and then it also offers you a controller by which you can turn on and off your sensors. Okay, now let's talk about the composition. I think this was one of the things that you mentioned in the starting. How do we compose? So there are different composition styles for a component. So first one is a sequential composition style. Basically, you have two different components. They don't know each other, like totally isolated, and they don't have a means to communicate with. Ideally, they should have if they are built in standardized way. But there could be the cases that somebody built them, they are not up to your, like they don't fit into. In the sequential composition, basically you build something, a glue code, you need an extra, something in between for them to work together, right? So that's one composition style where you put the components together with some glue code together. And then the next we have is the hierarchical composition, in which they directly interact, they understand each other's interface really clearly. That's another style of component composition. And then the third one is basically a mix of both. And we cannot independently, they don't talk, but they sort of offer you a richer functionality to a new component. Like the third example is like it's a bigger component that you're making by composing the smaller one. They don't interact with each other, but like they play a part in the big picture basically. So these are the three basic categories of component composition: sequential, hierarchical, and adaptive. Depending on the use case, you have to pick and choose what makes sense when you're composing your system. Which one does make sense? Okay, now the concept of component adapter. As we talked about, interfaces could be incompatible. That's where the whole concept of adapter comes into play. That you need to give it an adapter for these different components to work together. So let's take an example. In most countries you have this emergency services, right? So you call on a number and they know your exact location. How? So they have the way that underlying system works is like you go from a number, and your number is, let's say, stored in the database repository, in your address repository of these service, of these emergency services, right? They know your location. From there, they know your address, right? And then on the screen, they also know your location. When you are calling, they can actually see from where you are calling, and that's because they have a system which is like address, and then they have a map service basically which maps where you are. So you have a component that searches your address based on you. So your phone number goes to them. Based on phone number, they search your address, and then they put that address in the map service to give them access to where you are located, right? So this is like an example of this phone database, or your address is a totally different service altogether, which is maintained by, let's say in Denmark we have address service station, right? You keep your address one places, and all the banking and everything, all the services, they use your service. So it's like a totally isolated component that exists and then if somebody else wants to use, you need to build in a glue adapter. Basically, where you say, okay, I extract the address from phone number from this system, and then put it together into map component, which basically displays me things on the Google map where this person who is calling it is located. Right. So this is an example of how an adapter could play. Otherwise, these two systems, the maps and the phone data phone repository, they don't know each other, right? They don't interact with the so in that case you need to build an adapter, and that in that way you can actually get access to where the person is from. I hope that example is kind of clear in terms of where the adapters, what roles the adapters will play. Any questions, comments, thoughts on this? Is that kind of clear? No? Okay. Yeah?
Would you show these differently, like visually, like if you were to put it in like a diagram, or would you just put it?
Basically, you say these are two different components within the system, right? We have address component which basically takes care of fetching doing all of that stuff, and you have a map component, and then you will show differently, like you show how they are connected. You will build a connector to them in a diagram. Let's say if you are making in terms of human diagram, you will show what your adapter interface looks like and what it expects. And so in this example, this is just a plain code example, just to make it clear.
So would it be called just a wrapper or something?
Yeah, wrapper is a new way of calling it, but it's more of an adapter rather than wrapper. Yes, you can call it is a wrapper. But there could be adapters could be much more complex than simple wrappers that you have. For example, typecasting your string to integer, all of the wrappers that you've been using. It could be much more complex, and that's why they have, especially in this parallel of component frameworks, they call it adapter. But in essence, this is sort of glue code that you put together to make your like heterogeneous system to interact with each other. Now that is kind of clear. Okay. Good. So let's look into the example. So we were talking about this data collector, right? And we have sensor module in the form, and we have the sensor data collection module, which basically controls starting and stopping a particular sensor. And then in between there sits an adapter, basically that takes care of the calls that you make, the conversion calls that you make for starting and stopping and giving you the data. And it has clear interface for requiring what it needs and what it offers. Okay, we are talking about the component repository. It's like a data set of your components wherever, and one of the examples would be this Maven Central repository. This is quite heavily used in the Java world. Of course, in the .NET world, you also have something similar where you get your dependency repositories. So there you can get your components that you need. Okay. There's nothing much about the component repository. It's more about like where you get your component, which is a public repositories. There are plenty of them for each different subsystems. You will get different repositories. Okay. Now I think I have confused you enough. Now the next most urgent question in your head would be, okay, how is the component different from an object? We are saying, in one hand we are saying that, hey, component could be a small piece of logical work that we do, and it has an interface and it can interact with other, but that's also something similar to what we do in what object plays in object-oriented programs. So is it the same? So what is the difference between, now with this understanding of component, what do you think is the difference between an object and a component? Or there is no difference? Is there no difference? Anything that comes to your mind, like are they similar? Are they not similar? Or is like this?
Object needs other things to be developed alongside it. It cannot be developed on its own. It cannot function on its own. Other component can be developed independently.
Yes, that's as a component has its own sort of would have its own life on its own, but all objects they don't exist in isolation. They are just part of the something that you construct of it. Yes, that's a good distinction. What else?
Maybe when you start creating it, the focus of a component is in itself is reusability, and like the focus is different from when you're making an object. You're not necessarily thinking along those lines as when you're making a component.
Yes, that's also a really good point. So it's like in the level of abstraction that they offer, like when you're creating an object, reusability of an object is not your priority, but when you're saying building the component that all the principles that we talk about, the reusability, maintainability, all of that has like a center that's a key sort of things with the mindset with which you sort of compose them or build them. Right? Yeah, that's really good example. What else comes to your mind? What are they different? Are they similar? How are they different? Let's put it that way. Anything that comes to your mind. There's no right or wrong answer to this. It's just that the way a thinking paradigm, how it makes sense to you.
That components can consist of objects in order to perform their function.
Yes, that's also an interesting way to look at it. Is like components would have objects within them. You have when you are building component, you will of course have the objects within them. Yes. Anything else that comes to your mind? Okay. I think you covered kind of.
This is the question.
Yes.
If we're talking about objects, are we talking about objects in the context of object oriented?
Yeah, we're talking about the same thing. It's like you're essentially doing the same thing. You're creating an object from the class, and then you're creating.
I was just wondering if you develop component based in a not object oriented context.
It's that's a really good question. As I said in the starting, object-oriented programming is what sort of build the foundation for component-based system. Because without that, if you don't have the concept of object and isolation and things, then it's very hard to imagine like a component that works. Right? So object-oriented programming was the foundation, and that's why I said in the class, this is one of the prerequisites that you understand the basics of a component object-oriented world. Okay. In the OOPS paradigm, basically the objects represents the specific instance of the class, its method, field, and behavior, and how the object interacts with the other objects, other code, right? Composition is, on the other hand, it's like a higher level. It's an abstraction which could cover multiple objects into it, ready to make sense, to make it more logical piece of work. So it's a higher level of abstraction in which you could have multiple, you will have multiple objects to interact with. So that's the sort of main differentiator between the objects and component. So here's an example. So let's say you have a Swing framework from Java, and where you have many reusable components, buttons and other components that you could actually reuse from there. In case of object, like its whole life cycle like rests with the entity that creates it, and it doesn't have its own independent existence. So basically, the key differentiator between the objects and component, let's put it that way, is like A is the level of abstraction, and also the second is the most important is the life cycle. So object's life cycle is totally tied up to its the creation and programming logic that creates it, builds the object. But component for component, they are managed by the component framework. The life cycle is managed by component frameworks. And how it is managed, we will see a little later in the course, and then you will be able to appreciate it much more. But just for now, just understand that the components are managed by the component frameworks, and that's what makes them different than the objects. And of course, component will be having multiple objects when you're composing the component, they will inherently have the objects within them. Okay. Let's now look into some of the real world examples. Let's look into some of the real world examples. So if you were to build, let's say, e-commerce platform like Amazon, how would you, what components you would think of, like, what comes to your mind, like, what kind of components that you would have? Anything? Yes?
Shopping cart.
Yes, shopping cart, that's one. Yes, what else? Product. Yes, product catalog, shopping cart, what else?
Recommendations.
Recommendations, payment systems.
Login.
Yes, the user management, user yes, recommendation engine, order management. So all of these, see again, the way you can componentize is basically driven by the business use case that you have at hand. That would give you a clear picture as to what makes logical like separation of these boundaries and how you can componentize the system. There's no one sort of one fit for all formula that you can apply and say I get the right sort of componentization.
About categories or look at the product catalog?
Yeah, product catalogs is like. Yeah. Why would you like build it in this way? It's like if you were to upgrade this, let's say, only your card, right? Or if you only upgrade to switch to different payment gateway, right? Then you are not like shutting down the entire application. Right? In all of these commercial systems, the downtime, let's say, if they have a couple of minutes or hours of downtime, it's a huge business losses, right? So for these kind of systems, they even if they change the payment gateway, all of this happens within the split seconds, right? Then you don't even notice, and that's because the systems are built in a way that they're interchangeable. Let's say within the component, within the environment that they're running, you have one payment gateway component, and then you swap it out and put the another one. So it's just like, and the container just pings in. You can actually now there are techniques that you could do it in a live mode. Like you don't need to shut down the containers to the component containers for it to be effective. So you could do it in that way. Okay, yeah. So the modularity it offers, teams could be working on different sort of components, and you can update and upgrade different parts without affecting the other. Okay. Imagine you are building a healthcare system. How would you let's say use case for healthcare. How would you componentize it? Like, what component would exist in your system? Do you think of what components like make sense for that? Anything? Yes. Yes, patient management is one of them. Yes, good. What else?
I just have a question about what this is. Is this like a hospital system or is this like a government system?
No, it's like a hospital system, like health management system. Not a government system. It's more it's a hospital system, or it could be like even in Denmark. Like let's say you have Sundhed.dk, right? It's just not one system. It's a collection of different systems. It's not a one system for a hospital. It's like all over Denmark you have this single system that different hospitals are using. But that's why it's like healthcare system, but it's not individual per hospital. It could be the some case. In some places you will see that each hospital has its own management system, right? Like that would also be the case, but here it's general, like the healthcare system. If we talk about Danish, I think, right? So it's the same healthcare system that has been used in different regions, and all of them are using the same underlying same system. Yeah. What else? What are other components that you would think of?
Visit registration.
Like,
Visit registration.
yeah, that is part of. Of course, that would be a part of the patient management, right? You have like visits and scheduling of their visits and all of that. The patient management is appointment scheduling. That's also part. Then if it is in the end somebody has to pay that's why you would also have the billing system for this. Or let's say you are building, how many of you use the React Native or that kind of systems for front-end programming? Yeah. So in the React Native world also you have like this reusable components, right? Different that you could use across the pages, or you have this let's say like buttons that you build once and then you use it everywhere across the social media. So, yeah. Okay, what else? Most popular one that we all have used. So let's say if you were to build a Netflix system, what components that you think will naturally comes to your mind? Like what would this?
Yeah, the
Streaming is.
the recommendation, there would have to be an account,
Mm-hmm.
product catalog.
So yes.
I haven't used it.
Okay. Yeah, I think that's why user management, that's sort of standard that you see across the system. Content delivery, recommendation engine, billing system. So, and the way the current Netflix sort of architecture is, it's not a classical component-based system, because these are all the systems that are built after 2010. They have migrated to microservice sort of state, but pre-2010 system would use these all the classical component-based models that we just talked about, the enterprise Java beans and all of that, the previous one. Even the more legacy system use something like Core bar. The banking system, in some countries, the banking system are still using systems as old as Core bar. So yeah, but most of the pre-2010 sort of systems that have switched to microservice services. Okay, if you were to build something like Uber, what would your components look like? Come on, we all use Uber, right?
Similar options.
Similar things, right? Role matching, driver management, payment gateway. No, the idea that I want to give you, that whenever you start thinking in system terms, start thinking in terms of components and what these components will entail and how they will interact with these. That should be, as an architect, that should be a thing that should ring into your mind. And of course, and you have to adhere. You have to always remember all the principles that we talk about. All of them have to be followed. Adhere 100%. Okay. Now let's talk about, so we talked about the component frameworks and they could help you build these systems, but then there are some challenges also. Since this is an introductory lecture, I am trying to like even cover things that we should be covered in the last, once you cover the full course, then you should know what are the limitations that they offer. But since here we are just also giving an overview of what would like component-based systems would encounter, like let's say, or what they have encountered in the past, so to speak. So, we talk about, it's a good thing to, we are talking about reusability, and it's really good in terms of talking, but in real world, different companies are building different sort of these component models, and they don't talk to each other. So you have a model, let's say, a Java-based model from Spring, and you have a Home Plus from Microsoft, and these are two different component models. Ideally, they should it should be able to possible to interact with across the component models as well, but in real world they don't. There is the standardization, actually universal standardization lacks in there, and that makes it really difficult to use them, right? Yeah, this is an example of platform dependency and locking. Ideally, they are supposed to liberate you from platform dependency, but in practice, before, this is I'm talking about pre-2010, like a REST sort of world that you are all familiar with. Before that, it was really challenging. The platform dependency was really challenging to crack. Now it's no longer the problem because of the REST paradigm. Yeah, and of course the complexity in learning curve is also a really big challenge in the component-based systems. Okay, before we move further, I want to give you a quick flavor with one of the component model that has been used in the past. and you can see how obsolete it was. But since these were very primitive days of this whole paradigm, but you can still appreciate it. Okay, let's talk about the core world. So this is one of the component model, and it is basically the common object request broker architecture. It is based on the common object request broker architecture. That's what the short form CORBA stands for. Proposed by this OMG group, and basically what it does is that you have client, you have server. They both have objects floating into there, and then you want to talk between the objects in your client with the objects in your server. I know it sounds really odd, but in the old days, the applications would talk to each other in terms of objects, and that's where this whole paradigm of object request broker comes to. You have in the client side you have the ORB, which is object request broker on the client side. You have object request broker on the server side, and then you have IOP, which is like Internet ORB, like Internet protocol on which the objects would interact, and that's how this system was initially designed. So basically, again, you were asking about the components existing outside of the OOPS environment. That's sort of gives you an answer. Like even the legacy systems, they were built on this whole concept of objects interacting with each other. Without that, there would be no concept of component. So this is basically the main like structure of this component model, where you have where the objects in different applications, so client or server, they could interact with each other via the IOP protocol. Let's see how they do it. So you have client side, basically which has stub. Basically you compile a client, creates the stub for you, and that stub basically, which is nothing but this ORB, which is a stub that is created for this client code, that will again interact with the server. On the server side, you also have a stub that gets created for server code, and then they will interact with each other via. So for example, instead of TCP/IP, of course in the line they would be also using the TCP/IP. Are the internet protocols covered for you, TCP/IP and all this? So you are familiar with that. So all of the underlying they use it, but this was a specific protocol that was designed for interacting with the objects on the client and server in this model. So it offered platform and language independence, so to speak. So you could write the client code and server code in different language, and you have the objects compiled for them in different language, and then you create this stub by which the objects in the different language, they could actually communicate with each other. That was like the original idea behind this. So to offer the platform and language independence, support communication between objects regardless of where they reside. Basically, over the internet, objects would call. Defines object request broker to manage the request and response between the objects. So here we are just talking about the API. It's more of the object level communication that is happening. Okay, let's quickly look into the demo. I hope most of you have Dockers installed into your machines. Okay, then let's quickly look into and try to run this example. Is the code example visible to you, or do I need to? Can you see the code example? Or do I need to change the permissions or something? See if it is visible to you.
It is visible.
Okay, then just please download it.
I actually have a few problems with it. With the between error that backslash
Then we need to just, I think there is a space issue. Okay, please extract this somewhere into your repository, into your directory, and then we will follow this step. So again, this relies on Java 11 or less, because this whole OMG or the libraries that we are going to use, they are obsolete, they are no longer into place. That's why I need to put it in the container so that we install a specific version of Java for this to work, and so that you can see the.
So if we just download the latest JDK, that's going to be a problem.
Yes, because that latest JDK doesn't have the supporting libraries to run this. So I think the Docker container, if you run the Docker container, that should be good enough. So please extract this. Let me also open this example so we are all on the same page. So I'm just using the time of exercises as well for this class. Little bit, and after this I think we will be done. Okay, so if you have Docker installed, then let's jump into, first let's run it and then we'll dive deep into the code a little bit just to understand. So it needs a JDK less than 11 because some of the libraries that it uses are no longer existing in the new Java version, because as I said it's obsolete. So we have a Docker file here and okay, let's build this. Is it visible in the back? Is it or too small?
I think it's too small. I'm having problem watching
Oh.
seeing it.
Okay. I hope it is now visible. Let's see. We build the image, and that's this one of the reasons because it's using Java. I have the Java in my machine, but that's like the newer one, which I put everything in Docker. So once you have that, then you need to build basically the Docker network for client and server to interact. If you don't have that, then there will be issue between Docker stocking it within the machine. So this is nothing. This has nothing to do with the core the code itself. It's just a interaction between your Docker. So since I already have. I already have this network established because I ran it for this class earlier, and then we need to run the server first. We need to run the server Docker first. Okay. So since I already have the container running, I need to stop this. If you run it, so I just have the container running for me. I just need to stop it. And this should work. So now the server is running, and it has basically created this naming string. This is basically for this. So the client needs to know this, and by which it will know how to interact with the server. So this somehow server and clients need to know. Like this is a shared thing that they need to know, and that's how they would communicate with each other. This is like server on dynamic, on a runtime, it generates this, and somewhere you have to have this shared file, or you can also use this as a copy paste into your client code and then run the client code. That can also work, but I have set up this in a way that it runs seamlessly. It reads the server and client would read this like automatically. So it basically tells that starting port for initial object reference at this port number. So the port server is ready for you. And this is sort of client should use this sort of reference for when referring to this server. Okay.
There might be a problem with this. I tried downloading the JDK 7 and I had to log into Oracle in order to do that. So I can actually download it from the account.
Oh, it's a Docker when you are running the Docker compose.
You need paper hire.
Yeah.
Okay, let's.
And I just downloaded the yours.
I think I did the 8. No, 20.
I tried to run that.
No, with 25 it will not work. If you look into the Docker file itself, you will see that. I'm using this.
Yeah, that's what I'm trying to say.
Mhm.
It requires less than 11, and when I try to download 10, I have to download it from the archives, but I need to log into Oracle
Okay.
to do that.
Okay.
And I don't have an Oracle.
Really?
Yeah, so I actually can't download it.
Okay, let's run this example. Then we'll see each individual, like, because this is another problem. When you run this, it could be the case that different people have different settings of the Docker, and that could create a problem. So we'll try to run on each of your machine. But for now, let's look at the example, and then we will see how it. Okay, so this was now we have our server running, and let's try to run the client as well. And this client will send and do the handshake with the server, and this basically display you that I am interacting with the Corba server over the IIOP protocol. So yeah, that's what you get. We say the client says, hey, I am interacting with the Corba server, and this is coming from the server. Now let's look into the client and server code. So you have the client. So this is the org and the Corba that I was mentioning, that the all new JDK doesn't have this support. So that's why we need to adhere to. And this is basically the ORB that we showed. This is the ORB on which it would interact with the client. You need to specify. So this is the string for the object that we saw in here, right? So it said that this is where the client should listen to interact with me, and yeah, you'll see this all of these errors because you don't have the JDK installed, and that's why you will see this error, because the JDK that I have in this machine is different one, but we are just running it purely from Docker. So Docker will have its JDK, it will have made its dependency, and you will be able to run it. You don't need to install the JDK on your local machine. Don't try it, because then that JDK is of no use, because for the latest example you will have the other JDKs that you will be using. So this was on the client side. Basically you build the ORB, and you pass the reference where it should listen to your server, and you just basically saying responding to what the server says, right? Server gives you this, and then now let's look into the server code. Yeah, server basically puts out where it has the connection and what it expects. Basically, you give it a name, and the client should use this namespace for interacting with you. Same again. Remember this example. So basically it creates the ORB on both sides, and then interacts with the IIOP. Nothing fancy about this, but this is like sort of an example of how the object-to-object communication would happen in the legacy systems. Basically, you're giving it as a reference. Now in the REST space, we have the controller URI, so it's kind of underneath similar approach where each object that wants to interact would have its own sort of signature by which basically the server would know how to interact with that particular object itself. I hope that is kind of clear with how it works in the Corba system, how they interact with each other, and please try to run it, and let's see if you are able to run, and if you face any, let me know. How many of you are able to run the example? No? No one?
I haven't tried it.
Oh, try it. Give it a shot, and try it, and let me know if you this.
Yeah. I have done 1 and 2 when I want to I get this
Bash. Oh, okay, sorry. That would also be the thing, because I'm running it on the Mac, and you're running on the Windows. What is it? This thing to check. Bash node. Okay. Just check it. I think you're running it in Windows. See, it's not able to find the bash. So you should see what is the equivalent code. This is again the problem. But then there is no way I can test it on the Mac. So, how many of you have tried? Let me know if you face Any issue? Did you try it out?
And I still need to like set it up.
Okay. No, if it's just Docker, if you already have Docker, you don't need to
Yeah.
do anything. Just run the Docker command, and it should be fine because it has everything for compiling the code and everything. You don't need to install Java for now because that was not expected. If it was expected, I would have told you to install the
Yeah.
Java and everything. try. Just check what is the equivalent for Bash in the Windows world, and then just change that part. Anyone in the back that has tried? And yes. Did you manage to run? Oh, this is already existing. So this was the network part of that. To connect your Dockers, it's like between Docker network that is. You just need to create it once. It's perfectly fine. It already exists, then it's not an issue. Yeah, that's run that. Is your server running? No. The first command. Yeah. No, this is error. So can you increase the brightness? Is that? No, for the first.
What did you set up?
Just like open it up and stuff.
Oh.
And then the second one, 3D mass, and this you are not able to get it. Yeah, dash not found. I think that's just try to search what is equivalent to this. Dash not found in the copy this command and then say copy. It will give me the I don't know. I don't use the window. So then what is the equivalent of bash in the because it was only using for the bash. Did anyone with the Mac have tried it and make it run? Yes. Works for you? Oh, cool. I think that's the issue with the /dash command with the window. If any of you have found the solution, please update.
What's for you?
Make it. Okay. And your Docker installed? And is it ready? Yeah, that could also work.
What was supposed to do this? After the second step.
Did you manage to it? The same way?
Why did you get
Same?
error?
Ah, okay.
And which one? The first one?
Oh, the third one.
Third.
That's not wrong. Oh.
No.
You want to say the same thing with the
I'm
bash
not
command?
person to do it. I had to use bash somehow.
Oh,
You just delete the dash.
Ah, okay.
this error is it's perfectly fine. I think it should run on the Mac. It should be fine. Is works for you? Yes. How about you?
No,
What? Okay.
so that
How
means
is
both
the
works inside the server side.
Okay. So the people on the Windows that are facing issue, just remove the slash before the bash command, right? Yeah, before the bash, just remove the slash and then you try to run it. It should be fine. Do you manage to run? Oh, okay. Let me know if you take this. How about you? Do you manage to run? Okay. Open So client is okay. Good. Okay. Did you guys manage to run it? Okay. Sure. Yeah. It's the best one. Yes. Okay.
Do you
Okay, I
know
think most
what's
of
the
you
semester
managed to run it.
project
So
like
the Windows,
for the
Windows
fourth
just
semester?
try to
Like,
remove the slash before the dash.
I might have an idea.
It's about finding the
But I
dash.
don't know if they're gonna change it or not. If it's the same, then I might have an idea.
but the topic is the same, right? Like,
Yes, okay.
like the name of the subject
So I will
is
try
the
to
same, so it should
quickly
be the
look
same,
into
right?
the
Yeah, I
code.
guess.
Yeah, so
These are the stuff that basically you need to
I haven't
compile
really looked
this
at it
hello
yet, but
file
I-
and then you just build
I
this
haven't
builds
looked.
these interfaces. And these,
I'm quite
you
curious.
interact with the client via these interfaces. Like these are the clear interfaces for your class that by which you actually interact on both on client and server side. You see? You have the class, you build the interface, and then you work. You talk to each other via. Or
Like, how do you describe how it looks like in your own name, in your own
okay.
word?
You work with
I think it was like some kind of book recommendation system.
Book recommendations.
Book, yeah.
no, it's less than
That's cool. It's recommending it.
Because I think that's what
Yeah, I don't know them. I didn't really read the details, but all I know is like it's about books, I think.
I should have.
And do they develop it
the dashes there was less
web
remove the try to
or
remove
mobile?
Probably web, but I didn't know I did it.
okay.
If you go to my GitHub, you can like
Okay.
already find.
Alright, I think most of you managed to
already
run
have
it.
Yeah.
Let's quickly jump into the slides. I think we have few more slides to go. Okay. Now this is
Go to stars.
so the core bar this system was primarily designed for enterprise level sort of distributed computing environment. Of course, it sounds really primitive, but this, trust me, this a lot of legacy systems in the banking, telecom still run on this. Yeah, it was basically the middleware for communication between your being server and client into heterogeneous setting before
The startup
before
will
the
have AI
rest and
something
other
to do with
RPCs came into place.
recommendation feed.
Okay, let's quickly look into some of the limitations.
You meant that?
So the specifications it offers for the you remember I mentioned that each of these component models they have their specifications of how a component should be, and all of that is a really complex thing, and that makes implementation
They have
and
code
configuration
content.
really difficult. Especially this was a really small object, and we could see that it interacts. But imagine if you have a big business logic and have a fat object that does a lot of business processing. The interfaces could be a little bit be quite large and difficult to implement, especially because you are really working closely with the object, and the abstraction for you to is really low. So of course performance overhead, because in the network you are just carrying the whole information that is related to the object communication, and that's also introduces a delay and performance overhead in the network when you communicate. Imagine if you have a big object
What's in your mind?
communicating, taking it
I don't know, I
across the
haven't really
network.
read.
This was not optimized
I just
basically in
saved
that
it, but I
sense.
didn't really.
And also adaptation of this was very limited, because the modern web services and microservices basically killed it in one sense. You don't need
That's something
like
else.
better systems than this. So that's why it was mainstream for some time, but then quickly because the technology stack changed and it became kind of obsolete for thereafter.
I'm gonna have to start to see.
Yes, so to replace this, then came the web services, basically SOAP, which is also one of
But I
the
think they're pretty advanced than the
service-oriented architecture came into place, and along with that came the SOAP protocol for interaction between the services, and that took over, and then of course the REST came, and then the web services became the mainstream instead of this or object level communication between the subsystems. Then of course the gRPC, which is like Google's open source remote procedure call, that became quite popular, and it solved some of the bottlenecks that we see, like performance issues and all of that in server client communication that took over, and people kind of forgot that. Of course, the messaging services for distributed computing, messaging services also came into place where the client, does its job, publishes a message, and then server is also listening to the message queue and does the task asynchronously by using the message queue rather than interacting with each other directly either via REST or any other means. They work through a queue, both the server and client they talk to a same queue to take their next job and task. So then the queuing, messaging things became quite popular with Kafka and other streaming. They really help you, stream. For streaming service, the Kafka services also kind of became quite popular. We will touch upon this, all of them later in the course. For now, don't worry about this. Just the basic information that I'm sharing. All of these will learn in detail and touch upon because these are the modern sort of alternatives of what we just discussed. Yeah, and then the paradigm has shifted to now. Currently, the paradigm has shifted from the old classical component models to service-oriented architecture. Of course, the service, where basically instead of components, now we are talking in terms of service. We are not just talking about individual component that does some meaningful piece of work for you. Now, in the service-oriented architecture, the abstraction level has gone higher. Now we are talking in terms of a concrete service. Now everything becomes service. Now the interaction happens between service to service and not component to component. It's again the same thing in the service-oriented architecture. What they try to do is club the components together to now talk about service and service and its own interface and use communication and all that. Right? So that became main talk of the town. It was adapted for quite some time. So service became the main part rather than embedding the copies. Interoperable, it offered great deal in terms of interoperability. Of course, the service-oriented also has its limitations and which actually led to the microservices. All of this we will touch upon quite detailed in later classes when we talk about service-oriented architecture and also the microservices. So, but the next transition from service-oriented architecture happened to the microservices to overcome some of the limitations that service-oriented architecture introduced. So one of the key limitations that service-oriented architecture was about the limitations and the service granularity issues that came with the complex services and cost of maintaining these services themselves. Let's say you build a service, publish a service, and then to maintain the service become non sort of it was not a cost-effective means to maintain those kind of services, and then people started moving from the service-oriented architecture. That as a concept it was really good that everything is a service. You build something, you publish it as a service, others would consume it as a service by a standard protocol of SOAP. That was they built a specific protocol on how to communicate between services to services. And for that they use the SOAP protocol. This we will also cover a bit in the course. Yeah, it has performance issues and governance of the whole service-oriented architecture. Governance was also a big thing, and that led to actually that introduced a lot of complexity and that made people think to part away from service-oriented to microservice. Of course, now with the advent of Dockers and containerization, the whole theme of componentization actually has re-emerged in a new different way, and it's and that's why we will see also some of the modern way in which componentization is done by the help of containerization and and Dockers and Kubernetes, they have taken the same principles of componentization and made it like, really useful and handy for people to work with. And yeah. Okay, some of the common types of component-based architecture now is microservices, service-oriented, plugin-based architecture, and MVC pattern that you see also has some elements of componentization into that, because it again relies on the REST. This is again the modern like paradigm for communication between the services. So it has led to now these are some of the popular like architecture styles that people use in the componentized architecture.
Did you guys have a break?
Okay, so that's pretty much from this class. We covered about component-based system design, what it is, how historically they have been, and how the evolution has been, and where we are in this whole journey of component-based system right now. What are the key principles and the benefits of using the component-based system when you're designing a really enterprise-level complex system? And we also touched upon some of the real-world examples. So thank you very much. Do you have any questions, comments, or anything that you want to share in general?
I thought we were ending it as well.
Yes.
Typically, he said it's only 2 hours, but it's taking a little long. I don't know.
In terms of, sorry, come again?
He's an exception.
I was expecting more.
Korba, yeah.
Yeah, like you said, like, oh, it's like platform independent. I actually don't know what this platform independent is.
Okay, so what is the platform independent? So here in this example, we have both client and server. Client and server both were written in Java. Platform independence means, imagine your client was written in .NET. You can try at home. You can try the Korba client in the .NET or maybe in other programming language, and then make them interact with each other. So here, for sake of simplicity, I had both client and server both were written in Java in the same technology stack. Imagine you have client written in the one technology stack, and your server is written on the other technology stack, and you can still object written in C# can still interact with the Java object via Korba.
Okay, because like it said, like, oh, it's like platform and like programming language independent, I think.
Yes.
So I was like, it's probably something different than a programming language, but I guess it's like a tech stack. So
Yeah, it's a tech stack independent. Yeah, it's decoupled of. So you have different ways of creation of object in different programming language, right? And then they can the objects in different programming language, they can interact with each other. So that makes it's like tech stack independent, right? So you have client written in one language, server written in other language. How will they interact with each other?
So like, for example, .NET would be an example of something.
Yeah, .NET is a like example of different tech stack platforms. Any other comments, thoughts?
I think
Before we wrap
that's
up?
all. I think the project will quite push us into using any embedded elements because we have designing with embedded elements, right? Something with
Yes, that's
sensors
what
and cameras.
I think I will put.
Yeah,
I'll
this
update
one
the
is
slides.
this is like
Yeah,
Federation Cloud.
that's what. Thank you. Before we part, the next.
I don't know why, I just felt like I want to
In the
touch
next
sensors,
class,
you know?
we'll start with the
Touch cameras.
dependency management and
You wanna touch sensors?
basics of
It's not
Java
that scary.
Kotlin world. And for that, I need to know about
This one.
your familiarity with this Java world. So I would ask you to please complete this survey. So it will help me prepare better based on where you are comfortable with, what you are comfortable with. Okay. Some of you have already done this. If not, then please complete this. So basically 2 questions. I want to understand like how familiar you are with the design. Do you have some classes on design patterns in previous semesters? Use design patterns in that? Okay. We'll touch upon some of the design patterns that you have not covered in the previous courses that are more relevant for this. And also in general about the Java world. Don't be scared of learning new language because in the exam there will be no language specific question, there will be no framework specific questions. This course or the exam will totally be conceptual. there will be no framework specific question be asked in the exam. So don't be afraid. Try to use different frameworks of your choice or programming language of
So
your
it's going to
choice.
be multiple
No question will
question
be
with the
language or framework specific. So in that sense, don't be scared of anyhow you have to learn. Let's say if you want to venture into mobile development, you have to learn a new language. So don't be, because I noticed that in last days people have this mindset that hey, why are we made to learn a new programming language? You have to learn a new concept and you have
was
to
C
learn a
sharp,
new
I might
programming
say
language. It's too much
good
of work.
understanding.
No, here the emphasis is not in the new language. Just know the basics. If you, in the next lecture, what you will do is bridge the gap between what you know in C sharp and Java. You just in one lecture you will be very comfortable with playing around, and that's all you need. You don't need to be too deep into Java. If you just understand the basic, if you just understand the object-oriented programming, you are good for the. Okay.
That one is the back.
Please complete this, and with that I think we end for today's talk. Sorry, I took the later assignment part as well. But for this class, we don't have any assignment. It's just basic reading, getting the orientation about the course itself. We don't have exercise. But for this class, there is no exercise. For the next class onwards, we will have some exercises, take home assignments. Thank you. I'll see you guys on 5th for the intelligence system software semester project. So, yeah, see you on 5th.
He pulled out the 10th grade in the hardware. He really never comes on hardware stuff. And suddenly he gets like I was betrayed by the teacher.